Welcome everyone, Professor Bright here, and we are about to start the next section where we are going to be looking at functions again, but this time specifically we're going to look at the rate of change of a function and some additional function properties. And so here at the beginning you'll see, our main learning target. We want to talk about rate of change of a function over an interval at a point, talking about the graph and identifying properties as it's stated here. And so within that, right, we have all these different things that we have to do. Okay, so we have one main goal, and then figuring out how we get there are these learning steps. And so a few comments before we dive into the content. First is on note taking during videos. So as you're watching the videos, I want to encourage you to take notes, right? And so for some of you, it is enough to watch the video and, you know, get out the note template that's provided and write down what I'm saying. Great. If that works for you, fine. Some of you may not need to write everything down. Maybe it's just an example or two. Maybe it's definitions, right? Figure out what works for you. But either way, note taking, even though you have access to all the videos, really, really helps. Writing it down for yourself really helps. So I encourage you to take videos or to take notes during the videos. Next thing is I want to encourage you to always pay attention to the first page of the slides, even if you don't look at them all the time. Review them periodically as we get closer to exams specifically. Because when we write exams, what we do is we look at the learning targets, okay? And then we typically write a question based on that learning target. And so what we will try to do in a single question is capture as many of these learning steps as we can. Okay, so this leads to multi-part questions perhaps, but if you're wondering how to study, always ask yourself, can I, and then do whatever the learning target says, can I determine what the rate of change of a function over an interval or over an interval is or at a point is, right? If you can say yes, then you're doing pretty well. If you're saying, well, I don't know if I can, or you hesitate a little bit, that means you might need to do a little bit more studying. Okay, so just those two general comments. Now, kind of prefacing the work that we're about to see. When I and other math faculty think about pre-calculus 1 as a big idea, we're thinking about functions. We need to make sure everybody's well aware of functions, their properties, how they work, everything related to them. So that's sort of how we've designed the course. At the beginning, we have module 1, which is called Function Foundations. Okay, and so this is our module 1. Okay, module 1. Okay, and here, this is where we're truly building a foundation. We are looking at how function, or, what is a function? And then we want to understand behavior of functions. And then we also want to behavior of functions, and also we want to start figuring out what they can do. So this is when we look at applications, and different ways of using functions, and then how we can modify them. So this, how can, I can only do one thing at a time. How can we modify them? Functions. Okay, so oops, that's a question mark. Okay, so we're thinking after we get the once we understand what a function is, right, we're trying to see, why do we care about these things? What can they do? And just really understand the mechanics of functions. And that's why we call it function foundations. We want to make sure we have a solid foundation, because then in our later two modules, okay, we have module 2, which looks at specific sets of functions. So this is polynomials and rational functions. And here we revisit many functions that you might already know. We have the linear functions, so lines. we have quadratics. We don't do cubics as heavily, but in general we do polynomials. And then rational functions kind of in that order because they sort of naturally build. Okay, and rational functions are ones where you have fractions. Okay, so then we discuss each one of those function families, and then after that, once we kind of have that, we go to a different class of families in Module 3, which is exponential and logarithmic. So you've probably seen an exponent, right? But that in a spelling errors, logarithmic. Okay, again, I should maybe just write only. Oops, I should probably only write. Do one thing at a time. Multitasking is not my forte. Okay, and so here, really, we're looking at two classes of functions: exponential, which looks something like y, well, I'll do a function notation, f of x equals a to the x, so the variable's in the exponent. And then we also look at logarithmic, and you may have run across these before in, say, your chemistry class, because this would look something like g of x is equal to log base b of x, right? And so that's kind of the course map. Now, that's just a whole overview of where we have what we have to look forward to in this course. What are we going to look at coming up? Really, we're going to look at this second step in here, behavior functions. We're going to see, as if we look at a function algebraically, how does that connect to its graph? Right? And if we have its graph, how can we describe what is going on, right? As we go from left to right, it rises or falls, right? Maybe that's behavior. It has a hill, it has valleys. Or if we look at 2 points on this function and create a line, what's the behavior? What behavior does that line exhibit, right? All of those questions are going to be answered for us coming up here. So let's dig into the content now.